This is Autoline This Week, the show that gets you inside the global automotive industry. Autoline This Week partnered with the Consulate General of Canada in Detroit to produce this episode. And now, here is your host, John McElroy.
Thanks for joining us on Autoline This Week. Today we're going to be talking about some of the great research and development that's going on in Canada. You know, everybody talks about all the great things in Silicon Valley, maybe even in Israel, of course, in China too, but there is a tremendous amount of technology being developed in Canada. So joining me for today's discussion are Sarah Houde. She is the CEO of an organization called Propulsion Quebec. Saeid Habibi is a professor at McMaster's University. He's also the president of an organization called Eco Mobility. We'll learn what that's all about. And Ajay Kochhar is with Li-Cycle. He's the CEO there as well. And I want to thank all three of you for joining me today to have this discussion.
Yeah, pleasure to be here.
Thank you.
Ajay, let's start with you. And we'll be talking on a variety of topics here today. But Li-Cycle, anybody who knows batteries knows Li is for lithium. But what your company has done is developed a recycling process for used batteries that are lithium, especially for car batteries. I'm dying to know more about this because for me, electric cars, of course, are very green. But if we do not figure out how to recycle the batteries and end up dumping millions of batteries in landfills a decade hence, how green can that be? So tell me a little bit about your process and how good is it? I mean, how many raw materials can you extract from a used battery?
Great question and pleasure to be here, John. So just maybe taking a step back and we can talk about where I come from and the company, and then it will link into all of this. So personal background, I'm an engineer, chemical engineer. My co-founder, Tim Johnson, and I used to work in the lithium industry. So as you said, Li, lithium. And so we used to work on the mining and refining of lithium that goes eventually into batteries. And we're doing this for many years, working on projects. And this looming question that you just pointed out, what's going to happen to all these batteries when they die, kept on coming up. And there's a separate piece, which is critical materials. So a lot of folks may not know, but in a lithium-ion battery, it's not just lithium. There's also things like cobalt and nickel and much more. And so all of these are actually critical materials, meaning they have criticality for our economy. So that's the other question we were getting was, hey, when are we going to start seeing more recycled materials coming back into the supply chain? So, that was 2016. We got super passionate about solving this issue. And so we left our careers doing that as engineers and experts in the space and launched Li-Cycle. What's Li-Cycle? Li-Cycle, we are a lithium-ion battery recycling company, as you indicated. And so we innovated from the ground up a new process for how these batteries are recycled. And we're doing it today commercially. Historically, last few comments here, batteries have been really a waste. They've been treated as such. So at the end of their lives, they've been often treated as high temperature processes, and that loses a lot of the material. So to your point, if all of our electric vehicles are going to end up in that fate, it's not the best thing from an environmental perspective and also economic. So we, Li-Cycle, we use a spoke and a hub model, and it's 2 steps. The first step, very simply, we size reduce a lithium-ion battery safely. So that's a fancy way of saying shred it. And the secret sauce there is how do you prevent fire? How do you prevent thermal events? So very, very focused on safety. And the second piece is a refining technology, a chemical technology, where we recover, again, those fundamental building blocks, lithium, nickel, cobalt, and much more. Hasn't been done this way in our world's history. We're innovated right out of here in Canada. Started 4 years ago. We're now 60 plus employees, growing to 100 by the end of the year. And on this verge of expansion, really executing and building up our facilities.
How hands-on is the process, or how automated can it be?
Great question. So historically, it has been very manual, actually. So I'm just going to give an example here. So you say you have a Chevrolet Bolt. I'm just going to choose an example. And in the chassis of that car, there's a pack, and that pack has individual lithium-ion battery cells. And there's many of them. And that's what basically makes up a pack. So sometimes folks think that it's all, one battery, and actually in that pack, there are many, many different batteries. So historically, what recyclers would do is actually manually take apart that pack. So down to the individual cell level, manually dismantle it with a lot of labor, and that's not very scalable. I think you're probably starting to see, in a pack, you might have thousands of cells. So how long is that going to take? So what we do is it's completely automated in terms of the preparation. As we receive batteries, touch very minimally within a battery pack, there are modules, which are basically collections of cells. That's all we do. We isolate the modules, and that goes directly into the machine in an automated sense. And what that does is it reduces the risk of safety events, reduces cost, and makes it just much more streamlined. And what people would think, an automated, future-proofed recycling solution would be.
Okay, I'll be back to you with more questions. Don't worry, but let's get Sarah in on the discussion here. Propulsion Quebec, very interesting organization that you've got there, Sarah, because you're looking at all propulsion. We're not just talking electric cars in this point. We're talking a lot more than that. Please explain to the audience what all Propulsion Quebec is involved in.
So we are a cluster, which is a nonprofit organization that's both funded by governments and the industry to accelerate the development of this very promising economic sector. So that's really our mission. And so we have been in operation for 3 years. We have 175 members, mostly industrial companies, either manufacturing products or offering services within 5 subsectors, which are really the strengths in Quebec, industrial strengths, I would say. So it's electric vehicles. As you mentioned, we do not manufacture passenger cars in Quebec, but we manufacture all other types of electric vehicles. Let's take a spectrum. It's between electric scooter to electric trains and everything you can think of in between. So electric buses, electric specialized transportation trucks, heavy duty trucks, recreational vehicles such as Sea-Doos and snowmobiles. So everything you can think of except cars. So we have OEMs manufacturing those cars and manufacturers of components. So electric motors, for example, also all sorts of companies active in the battery sector. So also we have battery recycling companies, mining companies extracting lithium, nickel, graphite, and being very active in the battery, I would say, subsector. We also have companies manufacturing charging stations and operating systems. The systems in New York are from Montreal, and in a very close horizon in LA as well. We also have companies manufacturing smart infrastructures, hardware and software for connected and autonomous vehicles, and as well as companies active in the new shared economy for mobility, so car sharing, bike sharing, carpooling, that kind of thing. So we work all together, the industry with the clients, so the transit authorities, everybody that's buying all those things, and we were working together to grow the industry faster. So this is what we do at Propulsion Quebec.
Okay, you've got a great spread of members there for your consortium. What's the goal here? I mean, obviously to advance this technology, but how do you get all these companies working together? How do you plan how everybody should work together?
Right. So everybody in the world is trying to invent the autonomous vehicle, very performant, and same thing for electric vehicles with very high autonomy. Everybody is trying to go fast in that international race. And so what we do is we're trying to have the clients and the innovators working together to sort of identify the technological element that we all needs to work on, and how we can work together faster with government as well, because government needs to evolve with the regulation, with the legislation, with public policies that will support the clients to buy those kinds of vehicles or infrastructure, for example. We also need to work on labor issues because it's an emerging industry, and we need to make sure that we have the right trainings within universities or colleges or post-secondary institutions in general. We need to promote all those positions that are available within our company. So we all need to work together to grow it faster, because there are so many issues to tackle that we really need to sort of have a coordinating organization like us to sort of all work together and make it go as fast as possible.
Okay, I'll be back to you with more questions too, but let's get Saeid in on the discussion here. And
Sure.
Saeid, I got to tell you, when I was prepping for this interview and I was looking up a little bit of your background, I went, wait a minute, this guy is a mechanical engineer. I was expecting something else different, but obviously—
Mechatronics engineer, in between.
Okay, very good.
Okay.
So tell me what you're doing at McMaster's University, but especially let's talk about eco-mobility and what that's all about.
Okay, so let me just start by saying Canada is a great place to do R&D. As Sarah indicated, there's a lot of government support, and we have one of the jurisdictions with the highest level of automotive activities. We have plants from Ford. They've got two plants, the Oakville plant assembly, as well as the engine plant. FCA is present, GM, Toyota, and Honda, range of suppliers such as Magna, Linamar, DMV Electronics, and a number of others that we work with. So there's a lot of concentration of automotive activity that is happening here. And they can leverage investment into research and development in some of the best universities around. And McMaster is one of them. And we've invested heavily in automotive research. We created the McMaster Automotive Resource Center back in 2011. And within that umbrella, then we have a number of sub-centers. And we really span these sub-centers within Mark, and one of these centers is mine, the one that I'm the director of, which is Centers for Mechatronics and Hybrid Technologies, are looking at every aspect of the future of automotive and areas that are very important to it. So what we project is, as I'm sure everybody has been telling you, is that future is about electric fleets, on-demand mobility, and car companies will be not just looking at selling cars, but also at providing mobility. So branding becomes important, customer satisfaction becomes important, talent is important, technology is important, and that's where we operate. We are looking at, on the technology side, we look at electrochemistry of the batteries, and we have been working at CMHD, my center, collaborating with other research centers such as National Research Council of Canada in developing new cells, lithium silicon cells that we integrate in multi-chemistry battery packs, develop battery management systems. And we also look at characterization of these cells. And we worked with a company, for example, called DMV Electronics. We've developed one of the most advanced battery cell testers in the world, capable of Coulombic efficiency, impedance characterization, and drive cycle testing. They're marketing it internationally. And we work on developing test strategies for electric motor. My colleague, Dr. Ahmadi, who's a Canada Excellence researcher, is heavily involved with power electronics, development of motors, and design of vehicles. And we all collaborate very strongly with companies like Ford. I'm an industrial researcher with Ford Canada. And we work with Chrysler, BMW, and again at various levels of commercialization. So with OEM, generating IP, patenting vehicle platforms, suppliers, developing new products, supporting, and we have infrastructure that is very unique. I mean, in the picture behind me, you'll see one of two of these units in North America outside OEMs. These are chassis dynamometers that can do simulate turning on the vehicles. And so state-of-the-art facilities, engine dynos, electric motor dynos, and so on that we use for research And we make this available to startups. We support the startups with them, as well as do projects with OEMs. And we have our own commercialization as well. So you asked me about eco-mobility. Eco-mobility is the commercialization arm of CMHD. So we have a startup that I've done, and we essentially provide diagnostics and prognostics tools. We've developed sensors that go on end-of-line testing of electric motors, for example. We collect data, extract information from it, go through temporal and spectral analysis, and provide detection at 100%, diagnosis with 94%. And we also work in the area of battery characterization and BMS as well. So quick overview. I could go on for more, but I don't think you're going to let me.
Saeid, very interesting how you're doing this research in the university and now spinning it off through commercializing it, that is, through eco-mobility. Yeah. I've got to believe, too, not only are the automakers coming to see the technology you're developing, but the talent as well. As you know, there's a global race to get the talent. I've got to believe they're looking at you to provide that as well.
Absolutely. I mean, talent is the key. I have the startup, and we've got these huge talented students at master's and PhD levels. And I remember one of them, I wanted to take him to my startup. And 9 months, would you believe it, 9 months before he finished his master's, AVL from Graz came and offered him a huge big salary. And there was nothing we can do to do it. IBM, banks, all of this, because we work in prognostics and prediction, are just taking them. COVID has affected us, but all of these students are just flying off the shelf, and our own startups can't compete. Master students, 24-year-old, starting salaries of over $100,000. I mean, these are what we're talking about. We can't produce fast enough. And thankfully, we are in a jurisdiction that we can serve. A lot of my students are in Detroit, GM, Ford, FCA, in Apple, California, Graz, Austria, and Europe. I mean, it's incredible. It's a very, very exciting, and because we provide them with hands-on, and we send our students, for example, to Ford on internships. So not only they get the academic educational side, but they get industry exposure, and they have tools that are very unique in industry. So great training here, and a lot of demand for them, for sure. That's delightful.
Ajay, let's come back to you for a moment and talk about the recycling of batteries. You mentioned that you've got this automated process, which I love hearing, because you're right. If it's going to be very manual labor, you're never going to get the cost down, which leads to my question. How competitive from a cost standpoint can recycled materials from a battery be with virgin ones? And I ask that from this standpoint. All of the plastic in an automobile can be recycled. Almost none of it is, because virgin plastic is cheaper than recycled plastic. So how competitive can you be with your recycled material?
Fantastic question. And this is actually something we get asked very often. So I'm going to, again, kind of give you the background, what's been happening in the industry, and then where we are. So background has been basically lithium-ion batteries have cobalt in them, in the cathode. And not all lithium-ion batteries. You might have heard Tesla's Battery Day, where they talked about no cobalt cathodes, for example, but many do, and they're actually very common in our cell phones, so, and laptops and the like. So the historical industry has been very focused on cobalt. That's really what they've been looking to recover. We have changed that lens, and we want to get the full gamut of materials. In a lithium-ion battery, cobalt may only be a few percent. It could be a bit higher, so it's not really the majority of the mass. What do you have in there, right? You have plastics, you have graphite, which is the anode, you have aluminum, you have copper, you have lithium, of course, cobalt, nickel, manganese, right? There's a whole basket of materials. And so the lens that we take is recover all of them. And you have to be practical about what you're recovering. It has to work commercially, and we've optimized for that. And so to come back to your question, taking that approach, we then have the ability to have revenue streams that are multiple. So we can get revenue from lithium and nickel and cobalt. So done the right way in the medium term, we will definitely be cheaper than virgin material.
Oh my gosh, what a statement.
And I think the point I want to make, though, is that this market is growing so fast and the demand keeps on growing and growing. And I think one piece that's missed, and it's in little industry circles that we float around in, but is critical materials, lithium, nickel, cobalt. This is a strength point of Canada, but it's actually a bottleneck. And as demand keeps on increasing, we're going to need as many of these critical materials that we can get. And recycling is a good additive source, but it's not going to be the only source. We need both mining and we need recycling together to make this happen.
Yeah.
So this is a great business to be in. By 2024, you're talking about ICE cars becoming somewhat comparable to electric vehicles. And
from a cost standpoint, you're saying?
And from an overall cost standpoint. And there's a tilting point that is happening. And once that happens, the demand is going to grow. Already, material cost is going. If you look at the cobalt lithium, it's on its rise. And I think within the next 4 or 5 years, you're looking at a very steep increase potentially, which could be beneficial for recycling. So future is good for electrification. Let's just put it that way.
And I would also add that removing the extraction costs from the equation is absolutely key in the value of those materials, and being able to recycle them also adds to the branding of a green car. It's not only environmental issues, but it's also social issues with the extraction of cobalt, actually. So I mean, it's really a multi-impact solution to recycle the battery. So it's definitely a game changer in the electric car evolution.
And Sarah, let's keep talking about what you're involved in, because we're talking technology and lithium and all this stuff, but you're looking at the total system of transportation, including bicycles, including walking.
Absolutely.
The total system. Explain a little bit of your approach from that standpoint.
Professor Habibi mentioned it before. We envision mobility as being much more as a service, where you will be able to get the right vehicle on demand, the right electric vehicle on demand, and use it probably not as an ownership standpoint, but more as being subscribing to a variety of vehicles. Might it be bicycle? Might it be shuttles? Might it be, I mean, sometimes you need a pickup to go to Home Depot and buy some stuff, and your small little cars might be more useful when you're going downtown, and you will have a hard time finding parking. So it will be more the right vehicle for the right timing. And so we think in Quebec that we are already producing the right type of vehicles, because we are producing all those different types of vehicles. So we're really looking at it from a more general point of view, but we think it's very in line with the future of mobility. So,
but also, if you think about what's going to happen, I mean, we're talking about cost of battery packs per kilowatt hour coming down to about $65 by 2030. I mean, just imagine that. What's that going to do to transportation? There's already Rivian and all of these companies that are looking towards producing Tesla heavy trucks and so on. And kudos to both the provincial and federal governments here for looking forward a little bit into the future. There's a lot of incentives that through organizations such as Propulsion Quebec are given to automotive suppliers and companies to enhance that in advance of that reality. I mean, things are going to change. 5 years from now, we'd better be positioned for it. So it's a great field.
Yeah. And the thing I'd add to that, Saeid, is, you have this amazing nexus of different innovations that are needed all across the chain, right? I mean, I'm talking a lot about recycling, but battery manufacturing, as we've talked about, to the testing, to the vehicles. And you think about the scalability, right? What does it come back to? It comes back to ecosystem. And so we're all part of an ecosystem here in Canada, right? And that's all very important. But I'd love to go back to the talent point, right? And as a scaling company, honestly, this is our key bottleneck sometimes, just speed of getting talent. And Canada, I think, has done a great job of attracting that. But this is, as this all scales, every part of the chain needs to grow, right? And behind that is the people. And I think that's where we're going to continue to see really interesting trends, but also big opportunity and challenge for this whole supply chain from our standpoint.
Absolutely. 70% of our members identify labor issues as their number one obstacle for growth. It's really a cross-sectoral concern, and we need to promote more all those jobs that we have in our sector to the youth. I think other sectors have done great. You know, like in Quebec, it's video games have been promoting their jobs very well for years. Same thing for aeronautics and other sectors. So we really need to get out there and make it known, and also work with our universities to make sure that we have specific trainings for our industry. So this is really something that we need to do now in order to not miss any opportunity in the future, which we are already trying to avoid as much as we can.
Yeah, we need more battery and electric vehicle geeks, if I put it that way. Sorry, John.
I was just going to say, Sarah, you got me up on my soapbox, because I don't think that the automotive industry does a very good job of promoting itself. Sure, they have all this advertising for the cars and the latest deals and all that. It does not promote itself. And I think you've identified a key point that it needs to do. Unfortunately, we're going to have to wrap up this discussion. Sarah, Saeid, Ajay, thank you so much for your time, explaining what you're doing, giving us your insights. I appreciate it very much.
Our pleasure.
Thank you.
Thank you.
Thank you very much.
As I tell the audience every week, I want to thank all of you for having tuned in.
Autoline this week partnered with the Consulate General of Canada in Detroit to produce this episode.